Hello everyone, welcome to the second in our lecture series of this season. First of all, let me relay the excuses of our director, Professor Yuri Rockland, who could not make it tonight. That's why you guys are stuck with me. Tonight we have the pleasure of hosting Ariadne Kostomitsopoulou Marketou, who is a PhD candidate or student? Candidate. Right. Because there's a distinction with the university that I went. Candidate at the University of Oslo in the Department of Archaeology, where she is working on analytical characterization of pigments and raw materials derived from the late Hellenistic and early Roman production site on the agora of Kos, which is basically going to be the topic of the talk tonight. Other than doing a PhD currently in the Department of Archaeology, Conservation and History at the University of Oslo, Ariadne also has a background in science, Master of Science in Protection, Conservation and Restoration of Cultural Monuments from the University of Thessaloniki, and a degree in chemistry from also University of Thessaloniki. And actually, unlike most of us, she has been uniquely geared towards the work that she does today, with a lot of degrees and education in archaeological science and science in general. She has done a lot of volunteering work, mostly on roads in Kos and the Dodecanese, so a lot of practice. And although she has no publications at the moment, I'm sure that will change soon, she has also presented widely at international conferences, for example, Mexico, Norway, Croatia, Spain, Greece, of course, and others. The topic of tonight's talk is the matter of color, the material remains of the Hellenistic production site of the ancient agora of Kos. Before I let Ariadne take the floor, let me just inform you about our events coming up in March. Some of you may know this is our 30th anniversary, and we recently found out that we will survive. We will survive, but we will be pretty diminished, but still alive. The Institute, the University of Bergen, and also have decided to keep the Institute for the foreseeable future. So we will celebrate our 30th anniversary with that in mind. We have something that's we decided to call the 30th Anniversary Festival that consists of several different events. First of all, we have an exhibit that opens here on Monday, March 4th. It will be going on for 2 weeks. It's an exhibit from Norwegian and Greek photographers. And then on the 12th, we have a roundtable at the Swedish Institute about the current political situation in Europe. And then on Wednesday, the 13th of March, in the morning, also at the Swedish Institute, we have something called the Ecology Marathon, where current and former project directors will present the projects that that have been done through the assistance of the Norwegian Institute. And all of this will culminate on March 13th in the evening at the annual open meeting at the Acropolis Museum in Athens. So keep that in mind. Anyway, Ariadne, the floor is yours. Thank you.
Hi from me also. I would like to thank you for coming today, and Zarko for introducing me, and the Norwegian Institute for organizing this lecture and giving me the opportunity to share a part of my PhD research. Today we will be talking about pigment production, an intangible technological process approached through the material evidence of a Hellenistic manufacturing site that was brought to light on the island of Kos. This work is part of my ongoing research within the framework of my PhD project at the Department of Archaeology, Conservation and History of the University of Oslo. The overall aim of my research is a study of pigment production in the Greco-Roman world, taking as a case study and focal point the material remains of the production site of Kos. There, a number of pigments, including materials of natural origin, such as red, yellow, green and brown earths, as well as the artificially produced material Egyptian blue, were found in an archaeological context of a metallurgical workshop related to the lead and silver separation process. For my research, I'm trying to follow an integrating approach, trying to combine archaeological science, the cautious use of historical texts that refer to pigments, and the interpretation of the archaeological material from the site. With these methodological tools, I'm aiming to shed light to the technological processes involved in the production of pigments, and trying to find the operational sequences that were followed. The production site was found by excavations in the center of the ancient town of Kos, and more specifically here, in the area of the ancient agora, in the southern sector of the agora of Kos. And the site is located in one of the most important commercial and manufacturing districts of the town, of the ancient town, in proximity and connected with the ancient port of Kos, which was very important at that time for trade, with the famous exports of Koan wine and silk garments and other products of this island. The excavations in that area were carried out by the 22nd Ephorate of the Decanis of Antiquities in two periods. During the first period, from 1984 to 1989, undertaken by Haris Kansia, the largest part of the land plot was revealed, bringing to light part of the Hellenistic Eastern Stoa with its stilobate, the Agora's courtyard, and the Roman Tholos. On the east, two rooms here that belonged to the Eastern Stoa were brought to light. The production site is located in the area that corresponds to the northern room, while the southern room revealed a large number of bronze statues and statuettes and might be related to production activities. During the second period, from 2009 to 2011, the excavation was expanded, complementing the findings of the first period for the needs of restoration in that area. Yet, and unfortunately, the site has not been revealed to its whole extent, since the land plot on its north, that is out of this plan, was built without prior archaeological investigations, and the excavations of the second period suggest that the site would continue to the north, and this means that we don't have a complete picture of the workshop's layout. Here we can see the part of the site that is uncovered today, and an air photograph of the site after the destructive earthquake of 2017, which destroyed the restored portico of the Eastern Stoa. During the phase that the workshop was active, the area was dominated by these two walls, the green walls, 2 and 28, while the rest belonged to previous phases. It is most likely that it was organized on an open or a semi-open aired space where several fire structures were operated, indicated here with the FS. The two crosswise walls, 2 and 28, play an important role for the understanding of the workshop and its organization. They don't have any substantial foundations, and they are laid on a tile floor that originally belonged to a previous Hellenistic phase. These walls are related to the fire structures, the furnaces or the kilns that were operated in the site, acting as their support. Since the remains of the structures are not very well preserved and they don't allow their clear reconstruction, I will be using this term, fire structures, which is quite general, without defining their exact use. 3 such structures can be distinguished from their remains. While it is very likely that more were present, and that they were destroyed before the phase that the workshop was abandoned, and then rebuilt, and other structures were used for the same purposes. The first fire structure from the west, this one, is related to the production of Egyptian blue, where 99 out of approximately 130 pellets were found in situ. There also a large amount of pine cones was found. Here we can see some of them. And a sample of these was analyzed with the carbon-14 method, giving a time span from the 2nd to the 1st century BCE during the Hellenistic period, while the olpe that was found at the bottom of the fire pit gives us a more precise date during the second half of the 1st century BC, which for Kos corresponds to the end of the late Hellenistic and the beginning of the early Roman period. The excavations brought to light large quantities of amorphous lead lamps, such as these, and lead drops, and approximately 40 tubular litharge rods. And these finds point to the metallurgical process of cupellation for the separation of silver from argentiferous lead ore. Cupellation is a process that comes a bit later in the silver-lead separation process, as we can see in this diagram from Conopharos. And it involves the oxidation of lead that is in the ore to litharge, which is lead oxide. The base metals are dissolved in litharge that can have several forms, but here we have the litharge rods, while the silver is left unaltered in the hearth. Litharge then could either be used as it was, or it could be refused and reduced again to metallic lead and used as lead. In order to minimize the loss of silver, lead could be removed from the melt with the immersion of iron nails. In that way, lead oxide would physically adhere on the nail, and the result would be these litharge rods, with each layer of this onion-like rod corresponding roughly to one immersion in the melt. The excavations finds looked like the process carried out would be limited in the production of lead from litharge. However, from the analysis on a cruston of one Egyptian blue pellet, silver was detected, indicating that the whole cupellation process was carried out at the site. This sphere with the adhered silver brings us to Egyptian blue, which is the other material that was produced and treated at the site. In total, 137 Egyptian blue finds were brought to light in this quite small, as we saw, area, including pellets like these, both successful and unsuccessful, but also crushed and finely ground material that would be ready to be applied as a pigment. 99 of the pellets were found in the context of this fire structure that we think that is related to the production of Egyptian blue. The unsuccessful products that suggest also the production at the site vary in terms of color, and they can be either grayish, green, or purple. So what is this material? Egyptian blue is an artificial blue material that consisted the main blue pigment from the 3rd millennium BC onwards, and at least until the fall of the Roman Empire. And it was used for frescoes, polychrome statues, colored terracotta figurines, and it could also be molded for the creation of small objects, such as beads, and in some few cases it has been found as tessera for mosaics. So it had many uses. It is produced by firing a mixture primarily consisting of silicon, copper, and calcium, elements that could be added in the starting mixtures in various forms, as we can see here. Usually copper would be added, for example, in the form of metallic files, silicon as part sand, and so on. Additionally, and in order to facilitate the necessary reaction for its production, with the firing temperatures that could be reached at the time, alkali flaxes had to be added in the starting mixture. The firing temperatures range from 850 to 1050 degrees, and they should be kept. It should be kept relatively stable for a very long period of plenty of hours, maybe a couple of days. So it was quite demanding as a production. The final product is a multi-component material. That means that it consists of different phases, and its characteristic deep blue color is attributed to the crystalline phases of copper calcium tetrasilicate, which is this compound. That is the artificial analog of the naturally occurring mineral cuprorivite. These are the Egyptian blue, the cuprorivite phases, and an unsuccessful product with an optical microscope. This material could be further processed to produce different hues by crushing, grinding, and mixing with other materials. The production process for Egyptian blue is described in a passage by Vitruvius for the coeval 1st century BC workshop of Vestorius in the city and port of Puteoli in central Italy. According to Vitruvius, sand is ground with natron, which is a natural evaporite, and then filings of Cyprian copper are added, making a paste which is moistened by water. The paste is then shaped into small balls by hand, which are then left to dry before they are finally placed in a furnace. None of the starting material is blue, and this is noted by Vitruvius, who writes that the intensity of the fire impacts on the different qualities of the starting materials, and thereby they acquire their blue color. The artisans of Kos were following a similar process. A type of quartz sand, most likely local, was mixed with bronze files, since tin nodules were detected, I can't see it, but anyway, tin nodules were detected with the analysis. And the absence of calcium in the recipe that Vitruvius gives us has been interpreted as with the use of a sand that naturally contains calcium. However, the workshop revealed large quantities of lime, so the possibility of the use of lime as a calcium source cannot be excluded. The nucleation of the cuprorivide crystals, I don't know if you can see, but anyway, these are the cuprorivide crystals with a brighter gray. We can see that they are always close to the quartz grains, and this indicates a nucleation process of the crystals in a low alkali mixture without the creation of a glass phase. So this is also indicative of the process that was carried out and the recipe that was followed in the Khan workshop. Okay. The presence of a high iron content here, this white material is iron that is surrounding the quartz crystals in an unsuccessful sample. So this iron might be responsible for the unsuccessful productions, and it could point to the recycling of scrap metal for the production of Egyptian blue, since the presence is way higher than what we would expect if iron was entering the mixture as an impurity from the sand. Finally, the excavations brought to light several colorful earth pigment lamps. A selection of the materials was investigated with analytical techniques, revealing the variety and heterogeneity of materials treated in the workshop. The examined red lamps were characterized as red earths, with their color attributed to hematite. However, significant variance was testified in their chemical and mineralogical composition, reflecting on their final color. Interestingly, 2 of the red samples additionally contained lead tetroxide, and its presence might point to a local red earth source, or perhaps to an artificial pigment that would correspond to what Pliny calls sandix in his account on pigments. The brown earth lamps are composed of a complex mixture of iron oxides. The chemical and mineralogical composition of the yellow lamps showed that they are of different mineral origin. We analyzed 2 yellow lamps, this one, yellow materials, this small lamp, and this large quantity of yellow. The first, the small one, was characterized as an ochre, and it is composed of goethite and quartz, while the second was characterized as the mineral jarosite. The excavation revealed only one green lamp, this one, and it was identified as a type of seladonetic rock. This variety of materials and the observed differences in their composition illustrate the complex and sophisticated nature of pigment production and suggest that the workshop had a clear direction towards the production of pigments along the treatment of other materials such as the lead that we saw before. We can therefore suggest that there are 2 or even 3 productions if we divide the pigment production to the treatment of natural materials and to the production of the artificial Egyptian blue, that were carried out in the same workshop. Even if the stratigraphy of the site is very disturbed, the presence of silver adhered on an Egyptian blue sphere from the fire structure, which we consider to be an undisturbed context, shows that the 2 productions were in fact carried out at the same workshop, and possibly some stages of the production were carried out in the same fire structures, and most likely at the same time. It is very interesting, for me at least, to investigate how the different productions, pigments and metallurgy, interact in the context of this site. Earth pigments, and especially red and yellow earths, seem to be in abundance, according both to the sources but also geologically. But their qualities vary significantly depending on where they come from, on their provenance. Pigments coming from metal mines have been mentioned by ancient authors, and some were considered to be of excellent quality, such as the red earth from Kea, that Theophrastus mentions as the best red earth, which came from the iron mines of Kea. According to Vitruvius, the best source of ochre used to be found in the lead mines of Lavrion in Attica, which had been exploited for that reason, and as he says, a vein of yellow could be followed in by the miners in the same way a silver vein would be. Among the sources, Pliny the Elder accounts for the different pigments. He doesn't forget to include the gold, silver, and iron mines. The presence of important quantities of jarosite among the excavation's findings is quite interesting, since jarosite is a mineral that is primarily related to metallurgy, and argentiferous jarosite had been exploited for silver production in the famous mines of Spain during the Roman period, while its presence in Greece is considered to be diagnostic for silver and gold. The connection between pigments, and especially between the colorful iron oxides and oxyhydroxides, but also the copper minerals such as malachite and azurite, and mining technology, underlines the intertwined relationship between mining, metals, and pigment production. Beyond the ores that were found in the metal mines, the relationship between pigments and metals continued in the workshops. Iron oxides are known to be used as fluxing agents for metallurgical processes, and therefore their presence in such a workshop moves beyond their possible coexistence in the source. Moreover, Vitruvius describes the production of kerusa, today's lead white, which is a basic lead carbonate known as psimithion in ancient Greek, and for verdigris, or ios chalkou in ancient Greek. Both pigments are produced by the exposure of metals, lead and copper respectively, to vinegar vapors in closed vessels. The neighboring island of Rhodes is memorized by Vitruvius for this production. Kos is not known by the sources or from archaeological investigations for metal extraction and production in antiquity. On the other hand, neither is Rhodes, and yet, as we saw, Vitruvius mentions the neighboring island as the place where kerusa is produced, and excavations have brought to light a late Hellenistic workshop in the ancient city of Rhodes, where litharge was reduced to metallic lead. In contrast to Rhodes, Kos was known and exploited in the modern times in the 20th century for its galena ores. Galena is a lead sulfide, a mineral that often coexists with silver, but the possibility of the exploitation of these ores in antiquity remains unexplored. The location of the workshop, close to and interconnected with the port, could give an advantage in supplies, immediate access to fuel, which would be necessary for such productions, both for Egyptian blue but also for metallurgy, and also perhaps in large quantities that couldn't be supported by the island itself. And in the same time, it would facilitate trade, the export of the products of the workshop. The proximity of production sites to important ports, both for silver refining workshops as well as for the workshops for the production of Egyptian blue, such as the workshop of Astorius in Puteoli and the production sites in Memphis, might indicate a preference for their location, not necessarily close to the mines or to the raw materials, but in strategic locations for trade, both for import of raw materials and for exports of their products. Generally, pigments are materials associated with their provenance, demonstrating in that way also their qualities. However, it is known, for example from Vitruvius, that the workshops for the production of minium were moved in the center of Rome away from the original Spanish mines, perhaps because it would facilitate trade. Moreover, one of the most famous red earth pigments, Sinope, was named after the port from which it was traded, and not after the place of its extraction. Through the material evidence of the production site of Kos, where the different productions were carried out, we can approach the intangible technological processes involved. The characterization of the materials underlines the organization of the workshop around pigment production, with the treatment of ores for earth pigments and the synthesis of the artificial material Egyptian blue, shedding light on the early stages of pigment production and commercialization before the pigments entered the painter's workshop or the pigment stores. Kos can therefore be included in the sites known for the production of Egyptian blue, among Memphis in Egypt, which was producing Egyptian blue from the 3rd century BC to the 3rd CE in a large scale, and with the Roman sites of Puteoli, Cuma, and Liternum that are known from the sources, Puteoli from the sources, and Cuma and Liternum from archaeological evidence as production sites, illustrating in that way the organization of the production of Egyptian blue during that period. The interesting fact for Kos is that the production of Egyptian blue does not seem to be related to glass and faience production as it is in Memphis, but it shows a strong and intertwined relationship with the metallurgy and the treatment of ores. Further, this study might allow at least a partial reconstruction of the palette used by the Khan artists. But where all these materials that we analyzed and identified use as pigments? For example, jarosite that was mentioned also before, is not so commonly used as a yellow pigment, even though it has been identified in several cases, especially when it is compared to goethite, that is the yellow ochre. However, goethite was found only in a very, very small amount, this tiny lump, while jarosite was found in large quantities. Can we identify if jarosite is actually used as a pigment, especially since this mineral has a direct connection to metallurgy, and it may contain silver and can therefore be exploited for silver production through the cupellation process? Further research, including the study of polychrome statues or wall paintings, would add to our understanding on the use of color on Kos and the role of the workshop. Before closing this presentation, I wanted here to agree with Pliny the Elder, who after his account on the different pigments used by the painters, expresses his admiration to former generations that were using all these numbers and great variety of colors. I hope that with this presentation we might have a better understanding of this marble and perhaps elucidate aspects of their production in the Hellenistic period. Thank you.